I'm Dave Epstein, and today I'm going to be presenting our work on predicting unintentional action in video. Over the last 5 years, a lot of video datasets have come out that have ushered in a new era in computer vision where machines are able to take in as input a video clip and output some sort of understanding of the human action that takes place in that video. And these datasets are very large and they're very diverse, and so we can do a lot of things with them, but we made this observation that they all seem to share some sort of bias. And the bias that we believe they share is that the action in these videos is almost always intentional. It's almost always successful. So for example, in kinetics, more than 99% of the videos are focused on intentional action. I think for us, this is not exactly reflective of our day-to-day experiences. Today, when I was making lunch, I burned chicken and set off the smoke alarm. And that's something that I think happens to all of us at some frequency, and so we should look for a data set that's more reflective of this. And so kind of driven by this desire, we go out and collected this data set. We're calling it the oops data set, and it has more than 50 hours of videos just like these that are on the screen where action starts off intentional and everything is great, but as happens sometimes, there's this moment where things go wrong and then action becomes unintentional. And so we go out and annotate the moment when action becomes unintentional, this oops moment, and that's what you see flashing on your screen as oops. And the data set is collected from just random videos that people are uploading online, and it has a wide variety of different types of action, intentional and unintentional. It has some pranks, as you can see here. It has people slipping and falling, and so on and so forth. So now that we have this data set, and we have more than 50 hours of people succeeding and sometimes failing, we want a model that's able to detect this difference. So we want a model that can take in a video clip, and instead of outputting is the person dancing or skiing or eating and so on, we want the model to understand whether the action in the video clip was intentional or not, or is it at that moment when things just start to go wrong, at that oops moment. So it's a three-way classification task. And we indeed introduce a model as this kind of baseline trained on the training set, but the problem is that we don't have all of the training set labeled. We're an academic lab, and we only have the resources to go out and label around 35% of the training set. So that's something that we think is maybe more appropriate for fine-tuning, but let's go out and find a way to use this unlabeled data. And we want a self-supervised task to take advantage of this data, and it should have some relationship to whether action is intentional or not. So just pre-training it on a random self-supervised task may be less effective than a task that is designed to have some relationship with intentionality. And it turns out that there's a very simple task kind of hiding here that directly relates to the intention of action. And that task is predicting the time elapsed in video input to a convolutional network. And we think that the reason this task is aligned to intentionality is that the speed at which action occurs is related to whether we perceive it as intentional or not, as premeditated or not. For example, in the real world, from the perceptual cognitive science perspective, videos that are played in slow motion are much more likely to be seen as containing intentional or premeditated action as opposed to accidental action. And this has real-world implications. For example, when jurors are played slow-mo video as evidence, they're more likely to think the person pulled a trigger on purpose, for example. So we take this model that's trained on this task, which we think has this sort of relationship with whether action is intentional or not. And hopefully when we go and transfer the weights of this model and then fine-tune that same CNN on this classification task, it should do well. And indeed, we find that this is the most powerful self-supervised task out of the ones we tried to detect unintentional action. Please see the paper for more details on the procedure here. So before the talk gets too boring, I think let's look at the results, and this gives us an excuse to watch some more of these videos. So here we have some model outputs, the model that's trained on video speed and then fine-tuned with the labels. And on the bottom, the graph is showing the probability that the model assigns to each class as the video scans along. And so, here across a wide variety of failures, whether it's a kid wearing a cereal box as a hat or two bikers running into each other, the model is able to detect this transition from intentional to unintentional action, which is denoted by that yellow line peaking. I just show a few more results. The model is able to kind of detect people falling fast, detect people slipping, detect people running into things, and it's even able to detect pranks like the ones showed earlier. So if you're interested in seeing more model predictions or just browsing through the data set, downloading the data set, viewing the full paper or model code, please go to oops.cs.columbia.edu for more details, and thank you for watching.